Hicks, and I'm Director of Education here at the Santa Barbara Museum of Art, and delighted to see you here this evening. And even though we are, in a sense, tonight celebrating technology, I'm going to ask you to take a minute and turn yours off, your cell phones, anything else that might make buzzing noises during the talk. And I will tell you that it is being recorded and will be available on the museum's Vimeo channel, so if you miss anything or want to listen to it again and again, you'll have that opportunity. So, this evening, we celebrate the alchemy that occurs when art and science come together. A similar kind of magic may emerge as we bring together in conversation Michelle West, who curated the Observable Universe, Visualizing the Cosmos in Art, the exhibition of which Russell Crotty is a part and that's on view upstairs, and artist and amateur astronomer Russell Crotty, whose lyrical, labor-intensive drawings are featured in this beautiful and thought-provoking show. In addition to taking on the role of curator for the aforementioned exhibition, Michelle serves as the department curatorial assistant and is soon to become manager of docent and teacher programs within the education department, which makes me very happy. She received her undergraduate degree in art history, summa cum laude, from the University of Florida, Gainesville, and her master's in modern art history, theory, and criticism from the School of the Art Institute of Chicago. She has a rich and varied background in museums and the arts. For many years, she worked managing and assisting with artist residencies, and in 2012 was a curatorial fellow of contemporary art at the Norton Simon Museum in West Palm Beach, Florida. With her this evening on stage will be Russell Crotty, whose work was previously featured in the California Calling exhibition curated by our curator of contemporary art at that time, Julie Joyce. Since the early 1990s, Russell Crotty has made important contributions to contemporary drawing. Utilizing ballpoint pen as his primary medium, he's especially renowned for his distinctive drawings on paper-coated suspended globes, one of which is upstairs, and within large-scale books. His work engages astronomy, landscape, mapping, surfing, and coastal studies, along with an idiosyncratic commentary on the natural and man-made worlds. As a serious amateur astronomer, Crotty has studied the night sky for decades, utilizing his own array of telescopes with occasional sojourns to professional observatories. He obsessively and enthusiastically documents the night sky and celestial phenomenon. The resulting body of astronomical work is informed by scientific research, by contemporary astrophysicists, romanticized by his extensive knowledge of exploratory 19th century science, and fueled by his immense passion for the cosmos. This evening, he, with Michelle as his interviewer, will share with us the intricacies of his practice, insights into the work on view in the galleries upstairs, and most importantly, the inspiration that occurs at the intersection of art and science. Please join me in welcoming them both to the stage.
Wow.
Okay.
Quite a turnout.
Yeah.
Well, first of all, thank you, Patsy, and thank you all for coming out and listening to this fascinating artist. I'm going to let him wow you for the most part, but I want to give a little bit of introduction. And, when I was putting together the Cosmos show, or the Observable Universe, the very first artist that I thought of was Russell. I had seen his work at Hausfeld Gallery up in San Francisco, and he's one of, I think, the artists that really has a beautiful way of combining these very scientific concepts and making them accessible, making them somehow human. So that's kind of what I was going for in the show upstairs, and so he was kind of the perfect person to go to, and he was my first studio visit, which kind of led to a lot of conversations that really informed the show and informs his work. So we'll kind of start at the beginning, and I'm just, curious about how you got started with astronomy and drawing as opposed to other media, and where that came from.
Can you hear me?
Yep.
Okay. Well, I was always an obsessive drawer. My dad was a teacher, art teacher at College of Marin, and would bring home 500 sheets of paper a month for me, and I'd just sit there and draw all kinds of different stuff. So that's kind of where it started as a child. And I was always a little obsessive, kind of hyperactive, like a Ritalin kid. So, by the time I was about 12-ish, I was actually taking an interest in astronomy, and my mother, bless her heart, gave us, my brothers and myself, we could buy one book a month at this great bookstore if we were seriously going to read it or study it. So I got the Sky Observer's Guide there, and meanwhile, I had seen Jupiter through a friend's telescope. Actually, it was the high school's telescope he borrowed. And I was sort of hooked. I saw Jupiter and the Galilean moons, and like, whoa, okay, this is something I want to do. And my father had died recently, and I came down with type 1 diabetes, and so my mom was very enthusiastic about getting my mind on something. So I joined the local astronomy club and purchased a telescope. We saved up from gardening jobs and stuff and purchased this 6-inch Newtonian reflector, which was sort of like the hot little scope at the time.
Yeah.
In Sky and Telescope magazine, a good amateur all-around scope, which I actually used even years later when we lived in the Santa Monica Mountains, caretaking this property. And then I sort of studied the night sky from the porch there with binoculars as the constellations rose. So after living in cities, going to art school and living in cities, I'd kind of stopped the astronomy for a long time. And then we moved here, and boom, it just kicked in. And it was natural to sort of evolve out of this surf work I was doing, these sort of giant surf drawings done with a blue ballpoint pen. When I say giant, 10 by 20 feet with 40,000 images. Into something else. I'd sort of done that, so I was ready to branch into something else, and this just opened up. I mean, it was the whole thing.
How many years were you?
We were there for 16 years.
Yeah, I knew it was a while.
And there were absentee owners. They had no interest in it. They just wanted to keep a house standing there. Yeah. And it was standing till 2007 when it burned down in a wildfire. And then I built an observatory because there was 130 acres. So I found a spot that had already been dug out for a geological test, and built this roll-off roof observatory and outfitted it with a 10-inch Newtonian reflector, f8, which is, so it's 80 inches long, and gave superb views of things, because out over the Santa Monica Bay it would be really dark. Behind us to the north, you had the San Fernando Valley, and to the east you had LA. But up to the west, it was quite dark, surprisingly, actually. So there's a view down the tube of that. So by this time, I was actually doing lots of drawings at the eyepiece and notational, very classical stuff that a lot of amateurs still do. And translating, I saw the opportunity to sort of translate that into my work.
I was curious too, when you're doing that, just as a layperson who hasn't, how do you train your eye to do something like you're doing, where you're looking through a telescope and you're starting to try to sketch out, and what's that process like a little bit? Is it like smaller? Is that me? Is that better? I won't move. So are you, when you're looking through the telescope, are you doing sort of small sketches that you go back to later?
I looked at this as sort of a performative aspect of my work. I was thinking of it like that, because my studio was down the hill from the observatory. So I'd go up there, do the thumbnails, usually perched on a ladder, up high, looking through the eyepiece, and doing positional sketches of, say, star clusters or planetary nebulae, things like that. And later, I'd compile these things and then certain things would pique my interest, and I'd say, this will work in like a large atlas book. And the reason I was doing these large-scale books was I'd been doing these grid drawings of, say, Mars or galaxy types, morphologies. Again, some of these were 10 by 20 feet as well, like gigantic, and had thousands and thousands and thousands. It was sort of like the infinite, just keep going. And those, I thought of those cells, and I'd done a show in London at Cabinet Gallery, this sort of underground gallery in Brixton in 1993, and went to the British Museum and saw these gigantic tomes they had in these cases, and I was like, the classical atlases are big, and star atlases, why don't I do this, So I found some bookbinders, professional bookbinders, because I wasn't interested in actually learning to create books. I just wanted like a giant sketchbook. And so I started doing these elaborate, having them construct these elaborate books that would end up in my studio blank, and then I'd draw them. This one, for instance, is gatefolds out to 10 feet. So the drawing there is 5 by 10 feet. Two star clusters, and like big panoramic landscapes. I think that this one's owned by MoMA in New York, so I think they were photographing it. They put it up on the wall, it looks like, somehow. And that was like the view from the observatory, these forlorn wind-bent, Santa Ana wind-bent eucalyptus trees, and then the dry chaparral stuff, the yucca. And then I've always had this sort of interest in these outposts, or like Vandenberg Air Force, but you can't really go on there unless you have clearance. And so what's there? And so that was sort of, a bit of J.G. Ballard thrown in there for good measure, And, I did large books like this of just star clusters. This one was Atlas of Galactic and Globular Star Clusters, which is in the collection at SF MoMA. And that book's probably 80 inches across when it's open.
Were you doing any text at this point, or does that come later?
There would be text on the preceding page, but just kind of loopy. It wasn't like super repetitive or anything. It was just.
So I feel like I'm hearing feedback now.
Michelle, unfortunately, I think it's our system, not you.
Oh, okay.
Yeah.
Okay, as long as it's not me doing it.
So on the preceding page, it would say the M22 in Sagittarius through the 10-inch Newtonian or whatever scope I was using.
So just kind of descriptive.
Kind of descriptive, and then, I was on top of the ladder looking at this, and the owl swooped by, or just something, some notes about the experience.
So sort of journalistic in a way? I mean, do you feel that way? Does that influence the book format at all?
Notational, okay. And what I call bad poetry, since I don't consider myself a writer of any kind. So, because sometimes it's repetitive text. That's sort of like concrete poetry or something. This is the Great Red Spot on Jupiter in a red book that has 186 pages and was a flattened out views of Jupiter drawings that I had done over a long period of time. And they wrote, as you turn the pages, it was supposed to be a flip book, but it's actually large and very heavy. And as you flip the pages, you'll notice like that shadow transit of one of the moons there going across. Yeah. And I was invited by NASA. Is that me?
Sorry, that's working on. I apologize.
That's
like a
what
performance piece.
That's what it sounded like using.
Sound effects for the telescope.
Okay, well that goes well with the 60-inch telescope on Mount Wilson. I was able to use that telescope because NASA collection approached me and said, "Would you like to do a Mars project?" And I said, "Sure." And they said, "Well, what do you need?" I had access to JPL, to the Mars Global Surveyor imagery, as much as I wanted, and I could talk to the people there. And I said, "Well, I'd love to use one of the scopes up on Mount Wilson, the 60 or the 100-inch." And the 60 was available, so we used the 60 for some of the observations. And that's it. And that's a drawing I did, kind of a composite drawing I did. I'd done a lot of lunar drawings through my telescope. And Mars, pretty much, it looks like a much more eroded moon with an atmosphere. So I did these composites of different areas from the Global Surveyor imagery. And then as a side piece, it's a little smaller than that, actually, in reality. And then I did this kind of sidekick piece with my ranting text and about observing Mars and how difficult it really is. Because Mars requires magnification, and when you magnify things too much, you have to have like really steady atmosphere, or it's futile. So this is sort of ranting about observing it and ranting about some of the landscape and some of the Global Surveyor stuff. Just as kind of a side piece of like a block of text.
Mm-hmm.
Yeah.
And what size were these?
This one was small. It was like this, and it went next to the large one.
Mm-hmm.
And I was doing a lot of circular drawings like this because, when you observe through a telescope, you're looking at a circular field of view. And I thought that was just natural to sort of translate into drawings. So I did a lot of these 48-inch square drawings. That's a globular star cluster.
Are these done with the ballpoint?
They're all done with a ballpoint pen.
Amazingly enough.
It's archival ballpoint ink, supposedly. And there's the moon rising. It says moonrise over El Encanto, which was some development somewhere. I think it was up here, actually. It's up here. But that's not really El Encanto, you know what I mean? So it's art. You can make stuff up. And then there's Clavius. If you saw 2001, that's where the monolith was on the moon. Clavius. We've got to go out to Clavius. And through the telescope, it's quite magnificent. I think that was through my smaller 6-inch telescope. Because with my the telescope, you'd see more craterlets in the actual walled plane of that feature. And Comet Hale-Bopp came by in the 90s, so of course there was Hale-Bopp, and there was also Shoemaker-Levy that smashed into Jupiter, and I observed those. I did a lot of drawings and things around that. And this one, I think Mocha owns this one in LA, and it's 6 feet. It's really large. And the text has some H.P. Lovecraft stuff. Sometimes I like to put in things I like. And it says, beyond the waking world and the grayness of tall cities.
Yeah, so the globe upstairs, if you haven't noticed already, has the real estate terms on it.
It does, yeah.
And I think my favorite is the yummy new carpets.
Yeah,
All
yummy,
these real estate descriptors. Yeah. Kind of interesting, like thoughts on land ownership or land use.
Yeah, and also that was also in art speak, that was found text. Because I get the real estate magazines for the freebies,
right.
Especially when we lived in the Malibu area. It was like this really lurid text that I loved putting in as a strata in the landscape. So it had this dual function as a drawing and meaning. And there's one installed, and this was Win Komrowski's collection. He collected lots of drawing, he's a New York collector. And this was one of his traveling shows that went all over the place, but this was the iteration in Segovia, Spain. And then started working on the globes, and again, observing like this through a circular FOV, they call it, field of view. It just seemed natural at a certain point, looking at globular star clusters, in a circular field of view, to put them on a sphere.
Yeah.
And that's kind of how that happened. It kind of was, everything kind of made sense with this work, up to a point.
Yeah, it's kind of interesting with these too, and this has come up with some other people that I've talked to, about the globes, is this really interesting way in which you're taking our normal experience of the night sky, in which we feel like it's sort of we're inside that globe, and then making it three-dimensional. It sort of inverts the experience of the night sky.
Right.
So I'm kind of curious how you think about that in terms of there's this also tension that I think is in a lot of your work, and especially maybe apparent here, is this balance between this sense of accuracy and wanting to get something, an exact, specificity. This is a certain star cluster, or it's a, whatever this is.
Right.
But then, like you say, there's a certain artistic license whereby that once that image wraps, it doesn't quite, line up or
Right.
make sense. So they.
Yeah, I mean, actually, yeah, if you're looking at that, it's in this field, and it's like this.
Right.
And there's depth with the distant stars and things, and that's part of a supernova remnant in Cygnus called the Veil Nebula, but that's just part of it. But the rest of it is kind of made up.
Right.
I mean, the star fields, because, I can't map down to a certain magnitude, right?
Right.
And magnitude is how bright a star is. Like, it goes from naked eye. I think we're at a really dark location. We can see 6th magnitude with our naked eye, and with larger scopes, you can get up to 15. And with the biggest scopes in the world, Earth-based, you can get into the 20s, but not much farther, surprisingly. So there's limitations. But yeah, I did use a lot of artistic license with the fields of these. But the main thing was to sort of convey what the thing was.
Yeah, well, and I think there's a real interest in the three-dimensionality of it. I think that it's really striking to a lot of viewers, and it's kind of this phenomenological experience, especially, I think you have some slides in here too, of installations where you have multiple globes and kind of get a sense of the various scales of all of these. And
this one's 45-inch globe, and it was a globular star cluster. The globular star clusters are great for smaller telescopes because they have a bright core and then fringes of thousands of stars. And this is M15 in Pegasus, Messier 15, and it's a really good one. It's 36,000 light years away, where most of these things are 100,000. They're on the halo of the galaxy, so they're much farther away. The one in the show upstairs, there's one NGC 7006 in the constellation Delphinus, the dolphin. It's not far from this, actually, in the sky, but this one's really close by globular star cluster standards, and the other one's like really far away. So it's kind of fascinating. You start to get this idea of, if we're looking at the galaxy from one of these things, it would be like this. You're outside of it in the halo, sort of. And they're still trying to scientifically dissect these things. I mean, they're really complicated.
right.
They think they may have black holes in the center, and there's so much condensation of energy in the center of them. And there's 500,000 stars in these things normally. So they're beautiful. They start out in the middle here. This is the core, and usually you can't resolve it. It's just, bright. And then it, use what they call averted vision at the eyepiece, where you look at it and then kind of look away, let your eye drift away, and you can see details, So it's a thing you train yourself to do over time.
It's interesting too, like you say, there's, and I think this comes into play a little bit more towards some of your newer work too, but the sort of challenges even within like these very sophisticated imaging technologies of seeing certain things. Certain things are outside of our current field of view, essentially, or, so there's a certain amount of imagination that comes into play whether or not you could see it, so
Well, especially now with the exoplanets, the extrasolar planets, that they are populating. They think almost all stars have planets now. They used to think that maybe some did, and most of them were binaries or whatever. There were two star systems or triple or quadruple star systems, but even those have planets. So now they think there's zillions of planets in our Milky Way, and there's probably, I forget what they were thinking. Earth-like ones, like terrestrial in the right zone that might have water. There's, I think millions. It's a big number. But whether we'll find them or not is another story.
Right.
But they're finding a lot of planets. But they're strange. They're not what you think. I mean, they call them mini Neptunes, or they could be large terrestrial planets, but like Earth, say Earth, rocky, but too big. So the gravity would just squish you if you landed there. I mean, it'd just be too much. Or they're mini Neptunes. They're like somewhere between, smaller than Neptune. So, and of gaseous nature. That's a meteor shower. The Leonid meteor shower some years ago was really brilliant. We counted like nerds. We're sitting out there counting them and marking them down. We counted like 1,200, and that was from a fairly light polluted location. If you know that term, light pollution, it's when neighbors have big lights that shine in your face when they should be aimed down, and actually the authorities would prefer they're aimed down so they're not blinded.
Yeah.
So there's this myth out there that shining light on everything is going to protect you, but it's not.
No, it's actually worse, yeah.
Yeah, it's bad for the sky because it just goes up into the sky, and it's bad for animals too. So this is just a description of that, and this is actually owned by a research astronomer at UCLA that you'll see later on. And that's probably my favorite cluster in the sky, as me and 10 million other amateur astronomers, called the Wild Duck Cluster. It's Messier 11 in the Shield, that constellation, which is not much of a constellation, but it has a nice Milky Way star cloud. And this thing's sort of embedded on the fringe of the star cloud. It's just beautiful.
So how long would it take you to do a globe? Like, I don't know what size this one is.
Probably 3 weeks, something like that.
Wow.
But I'd be working on some other things too.
Mm-hmm.
But I worked 12-hour days when my career was really booming with this stuff. I was working 12-hour days every day, and packing, had assistants packing things. It was crazy there for a while. And this is the Wonder Bread Nebula. No, it's actually it's called the Dumbbell Nebula in Vulpecula, and it's a planetary nebula is when a star expands into a red giant, like our sun will. It'll start losing its gas out in sort of shells, like letting these things off like that, and the star collapses. It sort of becomes like a white dwarf, they call it, and it shoots out a lot of X-rays and radiation, which kind of undulates through these clouds. So these things are diffuse. You can't really focus on them, so you always focus on a star in the field. And they when you use averted vision on these things, they actually move. They're strange, very strange. So this is a bipolar one. And some of them...
Sorry.
There is a psychologist in the audience, I think. Where was I? Bipolar, but a lot of them are annular, like you're looking at them and you can see the central star, and then you can see the gaseous cloud around it. And sometimes through larger scopes you get tinges of color, like reds and greens. And that was a really nice installation of the Baja to Vancouver show, or no, that's for the record. That went to the Vancouver Art Gallery. And it just looked great. I don't know. That installation was one of the better globe ones.
Yeah, and the shadows are nice on that, actually.
Yeah, just the whole tone of the thing was really great. And then I did several really large books, that roll-up books, and had these tables constructed that folded up, and you could roll the chart book up and put it in that tube, and off you go. It's like a field guide. Mm-hmm. But it was more of a field guide for a museum. It's 7 feet tall by 12 feet long by.
Yeah, and it's a little hard to see in this video, but I saw one of these at your studio.
Yeah.
And those layers that look completely white there actually have some of your they're like transparencies. There's layering of
there's Dural architectural film over where I actually wrote information, and then you roll that back and you see like either symbols or that field. We have another one I'll show in a second. But so these two globes were the large 6-foot diameter globes, and I had a diabetic foot problem. If you're wondering about the shoe, it's not a new style, but and those are the two 6-foot globes from my show at Shoshana's some years ago. And this one is like a landscape of the Southern Sierra, the Domeland Wilderness. with the Milky Way above it, and the other one was a double cluster in Perseus, two not globular clusters, galactic clusters, which are much more open and delicate. And this one's in a private collection in Toronto, and that one's at the San Diego Museum.
And so you showed a slide there kind of at the beginning, but I think there's a couple later about the process of kind of how these come to be.
Yes, I think that's coming up shortly. And that's one of my favorite installations. It's a mattress factory in Pittsburgh.
Yeah, it's gorgeous.
Where they invite artists to do installations there, and it's a really unique place, you know. It's an old factory, and it became very luminous in this space, a lot of lighting. So here we are. These are paper conservators that would come out the studio and coat the globes. I'd have them fabricated out of fiberglass, and then they'd be delivered to the studio. Then Gabrielle and Lucia would come out and coat them, and then I'd have these big blank things to draw on. It's basically wheat paste and Japanese maza paper. It's very classical. There the artist brushing it on, the wheat pasting them down. The first coat, you'd use a little polyvinyl acetate, PVA, to get it to stick to the fiberglass, but the rest of the coats are all done with wheat paste. That's a great shot of that one. And then I was commissioned by the U.S. Embassy, Art and Embassies program, to do, they did the new, at that time, the new U.S. Embassy in Beijing. It opened around the time of the Olympics. So I did these three kind of California landscapes. I was doing a bit of seascape globes at that time too, branching out a bit. And then here's the second book, a large roll-up book. It was a little more elaborate, because in this one I started going into the center of the galaxy. The more you flip through it, you get these close-ups of like the Great Sagittarius star cloud, where there's a little thing called Botta's window that was discovered by Walter Botta at Mount Wilson Palomar Observatory. And you could see through it to the center of the galaxy, because normally you can't. There's this obscuring dust and stars in the way. And there's this one little window, which, with my scopes, I can't see through it, but I can see the area it's in.
Wow.
So I think this is another video. Should play. There we go. And the titles are very 19th century. There were a lot of like popular astronomy books called Recreations in Astronomy, Splendor in the Sky, that kind of thing, which are lovely to read. Actually, the language is really wonderful. So we didn't roll back all of the pages, because it's just, these things are really, I have to have these shot from directly above sometime, and then maybe zoom in or something. Mm-hmm. It's pretty tricky because they're so huge. And there's a person, that's John Weber, actually, standing there from the Institute of Arts and Sciences.
Yeah, the director. Mm-hmm.
Yeah. And that drawing is in the show, the NGC 7006 globular cluster there. The one on the end here. Okay, now.
So, you had this amazing opportunity. This was 2015, is that right? So there's a residency, a collaboration between UC Santa Cruz through the Arts and Sciences
Yeah,
Department.
Institute for the Arts and Sciences.
Yeah. So you were able to go to the Lick Observatory there and kind of go through their archives a bit and work with some of their equipment. And I was just kind of curious about what that experience was like for you as an artist coming in, with a bunch of scientists who are in some ways, maybe relate a bit because they're always trying to work towards these visual models too in very different ways. So I was kind of curious how, some of the older archive material and then also some of the kind of more cutting edge technology maybe influenced your work, or, how that collaboration kind of...
Well, actually went up to the Lick, to the archives, knowing what was there. I mean, I knew there were certain books I had to see, like observer log books. They have 3,000 of them there, from like the 1880s all the way up until the 19. Well, they still keep logs, actually, oddly enough. Maybe into the 70s or 80s, and then maybe computers took over then. But so there were certain people and certain things I was looking for. So let's see if we can get to an image of that. Oh, well, before we do that, well, no, actually, I'll finish that thought. So I did get to see actual drawings of Mars, very famous drawings that Edward Emerson Barnard did with the 36-inch refracting telescope, which at the time was the largest telescope in the world, and the Lick Observatory was the first mountaintop observatory in the world. So, it's a really amazing place. So I'd spend time in the archives, and then on other trips up there, or sometimes the same trip, I'd be able to use some of the equipment with a staff astronomer. And so that was one element of the residency. The other element was being on campus. And that woman there is Claire Max, and she's in charge of the University of California Observatories, which means the Keck Telescope, Hat Creek Radio Observatory, everything they've got, the Lick, and the new controversial 30-meter telescope that they want to put on Mauna Kea. So, and then Joel Primack is a premier cosmologist that came up with the phrase cold dark matter back in like 1980, and keeps telling me I should have got a Nobel Prize for that. And then the guy next to him is this fascinating character, Gregory Laughlin, who studies extrasolar planets and actually does these quirky kind of interpretations of sound. And I mean, he should be showing in a New York gallery or something. And this guy was really fascinating. But he left there to be director at Yale of astrophysics. But he wants to come back. He likes Santa Cruz. So those are the kind of people, and from there I was meeting with all these other people. And Raja Kuhasakurta, who studies the Andromeda Galaxy in gruesome detail, and let's see, Constance Ricosi, who studies like when a dwarf galaxy goes through a big galaxy, it leaves an imprint. It leaves a chemical imprint in the type of stars that it sort of drags through. Mm-hmm. And she studies those things. And I thought, wow, that's really poetic and beautiful.
Yeah.
I could do something with that. The problem is, like with all of these people, I kept saying, I could do something with that. I could do something with that. But it was so kind of overwhelming, all this information. So there's the observatory. That's the dome of the 36-inch refractor. And there it is. It's very Jules Verne. It became operational in 1888. And there's a little control panel down here, but it's mostly analog. It has a drive, so it tracks and all that. But so I was being trained on how to use it there by actually, that's Tony Mish, the archivist, and Eleanor Gates, who's like she's one of the other staff astronomers up there, and they help a lot of people with their projects and observing runs and things like that. So there's Paul telling me how to get the thing to move slightly. These things weigh tons. I mean, they're massive. It's 58 feet long. Wow. And shipbuilders built the dome for this. And the floors are supposed to raise and lower, but there's something wrong with the hydraulics right now. So we had to perch way up on the ladder to observe. It was a little unnerving in the dark. With this weight, the weight of this thing, it's just like, yeah. But really great experience, and the great early drawings of the planets, and early photographs of the moon were done with this. And a lot of other stuff. They added spectrographs to it, you know. And that was the largest telescope in the world until the 40-inch one went in Wisconsin at Yerkes Observatory outside of Chicago, outside of Green Bay somewhere. They didn't have as good a seeing as these people did. So yeah, and there's the 120-inch dome for scale. There's the Subaru Forester there. And these sort of cool, weird entrances that are sort of a combination of sort of neoclassical, but kind of 1950s looking too, you know. And that's Mike Rich, the guy who collected the globe with the meteors on it. And he's a research astronomer at UCLA that was studying, he was using 120-inch that night with the laser beams going up in space to read the atmosphere, called adaptive optics. And that's something they developed at UC Santa Cruz and Lawrence Livermore lab. And it corrects the light. They go into little deformable mirrors before it goes into the detectors, and you get these pinpoint images of stars, even on a windy night. And, you know, and they have a person in a phone booth on each side, outdoors of this dome, that look for airplanes, because they have to shut it off when a plane goes over. And while I was there, U.S. Space Command called them up and said, shut it down for 15 minutes, because they had a spy satellite going over.
Oh, wow.
Because the laser could fry the thing, you know? Yeah. So, but that's been a huge advance in astronomy, technological advance, adaptive optics.
I think one thing that's interesting too when you're looking at these sort of newer technologies too is we tend to think, oh, as technology advances, we're getting these better and better, more accurate images of space, but it's always dependent. There's no real perfect image of these things, that it's all dependent on the wavelength that they're looking at or the colors that they want to use. Like you said, you know, I think the Hubble images are
false color.
Yeah, false color, and it's enhanced. And so it gets kind of back to this idea of representation, the challenge for an artist, the challenge for anyone trying to represent something, and that it is something that they actually come across in science too, because there's no like perfect way to, scientific way to actually get.
I cringe when I look at the Hubble photographs of nebulae. I'm just like, oh God, that's horrible. Most people think, oh, that's beautiful, but it's really fake. You know, it's really not representative of what it's like. I mean,
I tend to agree. I think they don't register in the same way that some of these, and especially like the handmade element. I mean, maybe it's just because I'm coming from the arts, background, but there's something about, because I follow NASA on their social media, and it all just kind of washes over you at some point, and I feel like it doesn't really. I don't know. I don't feel the same access to it as I do when I know someone's intentionally taking artistic license. I actually find that more revealing, sometimes than.
Right. Well, that thing weighs 1,600 tons, and it's a 120-inch mirror, and they used to take long exposure photographs from a cage at the top, on top of the secondary mirror at the top. It would go down. It was prime focus, they called it. So they'd go up this kind of thing that would go up the dome there like that and step into it, and they'd be up there for hours, and they'd go up with a thermos of coffee and come back with something else, I mean, because they were up there for like on a winter night 12 hours, and they offered to let me go up there, and I watched them go up and look into it, and I just couldn't handle it. It's like no, because the dome's moving, the scope's moving, the thing's moving up the side of the dome. It was like, I have video of it, but it's really loud. That's why I didn't include it here. It's really caustic. So there I am working with this Paul Lynham and the other staff astronomer. There's Eleanor Gates and Paul Lynham, and we're doing an electronic night with a 40-inch telescope called the Nickel. It's used by a lot of students and for student research projects. It's a 40-inch automated scope. So we did an automated night like this, just from the control room, looking at a list of objects I gave to Paul there. And like NGC 6791, that's in Lyra, and that's 7006 again, the one up there, the very distant globular.
Yeah.
And here's what it looks like. I was asking him about the color, and he said, that's just random. Some programmer put that color in
Right.
there. And these artifacts were in it that actually looked really beautiful and reminded me of a lot of hard edge abstraction. And so, my mind was sort of going in those directions. And he kept saying, this is, the art science thing, he goes, this isn't science. This isn't science. Like what I was doing, that's not science. So that's NGC 7006 through the 40-inch. And maybe a couple minute exposure with the CCD camera. And you can see the core and then the fringes around. It's just something very compelling about that. That it's a thing that orbits our galaxy, basically. That's the Saturn Nebula in Aquarius. That was another thing we looked at. There's a central star that's sending X-rays out into the cloud and makes it, have this undulating feeling. And that's Neptune with some of its satellites. I was kind of interested in looking at the outer planets because of the discovery of exoplanets, and when they start to get to a point technologically where they can actually image them. Right now they do have some face-on solar systems where they can see a pixel-sized image of light. But with the new 30-meter telescopes and bigger ones they're building, and the Webb telescope that's going to go up in space, they maybe actually get little disk images and measure the atmospheres and things like that to see if it's either terrestrial or gaseous or whatever. And it sort of reminded me that Galileo 400 years ago did the same thing with Jupiter when he looked at it through a real crude early refracting telescope and noticed the moons. And that sort of blew the lid off Earth's placement in
Right.
the universe, So I think we're on the cusp of all these things, and it's a real fascinating time in that sense. And then they switched it over one night so I could use it visually with like this 100-millimeter eyepiece. So there I am drawing something. And then this is Tony Mish, the archivist, and he was a staff astronomer up there for 20 years at the Lick. And since he's retired, he's taken over the archives, and it's just amazing. All those drawers are filled with glass negs, and you can look up in the log books. Like I was looking for this two of this guy Kinman's shots from the 1960s of two of my favorite star clusters. So I looked it up in the logbook, found the dates, looked it up in the drawer, and boom, there they were. And you could put them up on a light box and look at them.
Yeah.
And then there's the logbooks. Like those are from 1888 to up into the 1950s. So there were quite a few different astronomers I looked at, and this guy, whoops, not that guy. There I'm talking with Tony. They're examining really beautiful notational stuff. And these stuck out. These were R.J. Trumpler, who studied star clusters, but these are actually drawings of the atmospheric measurements of Mars, of the atmosphere. And they're just beautiful. I mean, looks like conceptual art or something.
Yeah.
And then there's the one of Barnard's Mars drawings. He discovered the fifth satellite of Jupiter visually, and they called him the eagle-eyed astronomer. And he also used a lantern camera. He like this big lens, and it's called the Bruce camera. And he used this big wide field lens and was the first to take these really detailed pictures of the star clouds in the Milky Way and dark nebulae. So that's the other piece in the show up there is Barnard 92, 93, which are two dark nebulae against the small Sagittarius star cloud, which is it's parts of it are resolvable, but there's so many stars, it's like a haze. It looks like a light sandpaper, kind of. And these dark nebulae are just sitting right in front of it, just jet black. I mean, amazing. excuse me. And there's Tony with some students. So a lot of students, he's trying to generate interest in this stuff to keep the archives going. But here's a scope they allowed me to use on my own. It was a 22-inch telescope called the Tauchman. It was built in the 1930s. And so I learned how to use this thing and used it on a few occasions. Really nice scope, but doesn't get used much, just kind of sits there. Okay, so you want to?
Yeah, so, in terms of the project that came out of this, it's really fascinating. I also kind of can appreciate that, when they ask you to do a visual component, you decided to basically illustrate the history of everything. When I got to do a show, they asked what I wanted to do, and I said, I just want to cover the observable universe, no big deal, just, just go for it all, why not? So, so this is a really fascinating project that came out of the residency and was shown at the ICA there in San Jose, right? And then also later
at Orange Coast College.
Yeah.
So basically, the way I approached this, because everything was so fascinating, my brain was exploding every day after I visited with all the astrophysicists. I'd go back to the hotel and just be like, like it's all great, but what do I do? I just don't know how to approach this. And I was thinking of doing wall work, and Laura, my wife Laura, was saying, don't do that. They want you to do something different, do something new, and maybe something three-dimensional or whatever. And I had met with this astronomer named Garth Illingsworth. And he studies early galaxy formation, like we're talking 13 billion years ago or more, and on the edge of what the Hubble can see, really. And he gave me this chart. He said, well, and I said, Garth, what do these early galaxies look like? And he said, blue blobs. And it's like that resonated with me, like as an artist. A blue blob, okay, let me think about that. And he gave me this chart, and he said, well, here's like the present day universe here, and it sort of goes back to the early universe, to the cosmic dark ages, to the inflation Big Bang period there. Then it cools down in the cosmic dark ages, and then it reionizes. You get these supermassive stars that are really unstable, and they explode, and all of a sudden galaxies start to form. So right around the reionization there. So this is what the cosmologists are all looking at. And, there's observers like Garth that go and get the images, and there's this kind of odd, the observers don't quite believe the theorists. Like the theorists come up with these great ideas, but the observers are skeptical because I haven't seen that. How are we going to see that? Or we haven't seen that yet. I sat in on around a lot of conference tables where they were going on about this stuff. It's pretty interesting. Yeah.
Before you go on, could you talk about the concept of look back in time, the title of the show, and how that relates, starting with this, look back in time?
Okay, well, the show at the ICA, at the end of the residency, that culminated in that show, we had Tony did a whole section of archival stuff. So it was looking back at the Lick Observatory.
Right.
And then I had my older astronomy work, like some of the large books and globes and drawings. And so it was kind of taking a peek back at that epoch. And then this piece, this project rather, and the whole thing was called Look Back in Time. And it just all kind of made sense. So started, there's the map. Laura's a graphic designer, and she participated. We collaborated on this. At the ICA, her name couldn't be on it because it was related to the residency,
right.
Sort of institutional, whatever. And when we did it at OCC, it was a collaboration. We redid it, and she got the credit as well, which should have happened in the first place. So she did this map, and it would have been rather drab without the spectra kind of separating the contemporary universe from the old universe. And then here's the beginnings of it. Like, how do we do these things? They look like shower curtains. What do we, they're basically like craft netting with bioresin and drawings attached.
Sure, yeah. Our collaborator
Yeah, go
here.
ahead. Yeah, go ahead.
I just want to add that the space, the given space was 26 by 26 foot room. And so that's, the map that you just saw was after all this experimenting.
Right,
The
that.
original concept was he had to create, it was his project. I pushed him far enough where I had to help him because it was
Yeah, she pushed me into something that was a little over my
It
head.
was a little bit.
Yeah.
Anyway, the space given was a 26 by 26 foot room.
So here it's starting to take, the idea is starting to take shape. Like, okay, we can hang these things, we can use color somewhere in there, the spectra, we'll have a black hole. I took an old globe that didn't have paper on it, and just painted it dead, flat black. And ironically, they're finding they think there's lots of mini black holes all over the place now, like between star systems, just floating around.
Just hanging out.
Yeah, little ones like that, like 2 feet diameter. So space is getting scarier all the time. So this experimentation went on until we finally kind of figured out how to make these scrim panels that would come down, and I successfully adhered lots of drawings to some of the experimental ones. And there were lots of drawings involved and laid out. And then Laura was slaving away with the sewing machine, getting these things kind of where we can run dowels through them to keep them fairly rigid when they hung. There's laying out one of the pieces. There I am using bioresin. It's not, it's a very low VOC epoxy that the surfboard industry is using a lot now, and it's derived from pine sap. So it's way less harmful to the environment and you while you're using it. I wore a mask anyway. And there's the experimental black hole panel, and then there's the actual black hole panel, and you'll see it coming up. There's the spectra, because that's so fundamental to how they measure things and even velocities, whatever, the spectra is fundamental to astrophysics. So we had that, we decided that would be the dividing line between the early and the current. And then the cosmic dark ages are just sort of wigged out. It was really fun. Sort of throwing different threads on there and leftover pieces from ones we had cut up, and because I wanted kind of a cool blue background, and then light blasting off the wall behind it. So the light would be the Big Bang hitting the wall. That would be the explosion, and then the cool down universe, and then the things start to form, as you move up in time.
How much of this do you feel like was more imaginative? Like, I know some of these things you can kind of work out through astronomy, but
they're all sort of based on that. But I think the approach to this was a very handmade. Obviously, I'm using Sculpey clay, and those are little foam balls that you get at Michael's. Mm-hmm. And I used vinyl spackle, let it dry, and then I'd resin them. Just kind of lowbrow. I got these from the surfboard foam place. They had some extra foam in the backyard. Asked them if I could have it, and they said sure, to make the blue blob galaxies.
Mm-hmm. And then some of those smaller drawings that you had that were on some of the scrims, were those specific
they were
kind of cluster things, or is it more?
Specific, well, some of them were. The ones, the intergalactic panel, that's stuff in our own galaxy. Yes, those are things I've observed. The exoplanet one, no.
Yeah, because we don't know.
That's all imaginary, right. And the galaxies are just sort of a morphology of galaxy types.
Okay, yeah.
Really. And these were I tried to do a supernova flat on a panel and it didn't work, so we decided to make these sculptural things that look more like planetary nebulae actually, but they were supposed to represent supernovas, and they're quite beautiful though, with the light coming through.
Their own pieces. They could
Yeah.
be. Yeah.
So that added another element, but it was all very handmade, very kind of funky, you know. But it was inviting. So you'll see when we actually get to the final installation. So these are still all the things in the more cramped studio, just different shots to see how things would work together and get an idea. The whole thing took 2 months of work. And that's the announcement for the show, which was a studio shot. So it's not actually what it looked like. And then here's the actual installation.
Wow.
So you have stuff in our own galaxy right now, the globular clusters, all that stuff that we love. Then there's galaxies that are fully formed, black holes. Let's see. Black hole. And then there's a close, you can see closer some of the things that are recognizable there. And galaxies and stars. And this one we were real skeptical about because David Bowie had just died, and so it's like Ziggy Stardust. We kept calling it Ziggy Stardust because we were throwing glitter on it and just kind of freaking out. And it, you know, it sort of has the colors of stars, like the blue stars that burn really hot, the red stars that are cooler, the main sequence stars like our sun, the yellow one. But a lot of glitter and glam in that panel. Exoplanets. So in any other solar system, if you were looking back towards the sun and there was an orb there, you'd see crescent, you'd see phases at different times, and probably pretty interesting ones in multiple star systems with planets. So that, and then there's a close-up. So you can pretty much imagine anything, like a purple planet, a blue planet, whatever. A Jupiter-like, there's a lot of Jupiter-like ones.
So a lot of the sort of exoplanet stuff, were you interested in that before? Did that kind of come up during the residency more so? Or were there things in the residency that kind of, you know, astronomical things that really excited you that you didn't know about before?
Yeah, well, like talking to Connie Ricosi about the creeks, these sort of tributaries going through the galaxy, that just blew my mind. I mean, it's like poetry. The exoplanet people, I talked with several people that were specialized in that, and that was really fascinating. And they were telling me about extreme planets, like ones that are right next to their sun, that are giant Jupiters that are boiling, you know, that there's one that goes out and freezes and then comes back in and boils, and then goes out and freezes and comes back in and boils. You know, it's just crazy.
Yeah.
So, and I was looking at a lot of, you know, they were doing a lot of things on a board, you know, explaining things. It was great. Spectra with asteroids. Then we're getting back in the early universe, the early galaxy formation, and the blue blobs, and the filamentary web. This thing, if you see any simulations of the universe expanding from the Big Bang, you'll notice it goes off into giant spider webs. Just, you know, the whole universe is made up of this. And they just recently found that hydrogen is connecting everything too. Like a supercluster of galaxies over here is connected to a cluster of galaxies over here with a filamentary web of hydrogen. So it's just all over. And it was also an homage to Ed Moses, so the artist, who did a lot of really cool kind of diagonal brushstroke, large-scale things. And then we did a lot of hole punching of colored paper that I'd hand color the paper, and then like thousands of them for these different panels. So there it is. I think that's my favorite one of the whole thing, because you see all the stuff through it. And is it one of the supernova? There's some supernovas. That's the cosmic dark ages in the back. You can see it's really brightly lit. So it's just sort of cool blue, with a lot of stuff floating around. Just, there's nothing you can really focus on, which is probably what it was like until it started to reionize. And then things started happening, like these supermassive stars, which were these big bluish things, they think, kind of bluish, reddish. Not reddish, more hot, like purple, blue, purple. And then they just blow up because they were unstable. And then the galaxy started forming out of that.
And this whole installation also, we should mention that you could walk through, right?
This whole thing was meant to be walked through and, an immersive experience. Mm-hmm. Which I dealt with the globes before, but the globes, each object was specific to itself, and they were hung like drawings,
right.
54 inches on the equator, 56. Whereas in this one, there's just various things going on at different levels, and so you're meant to walk through, yeah. Mm-hmm. Mm-hmm.
Yeah, so sort of walking back in time.
Yeah. And you'll see some of the names in the show upstairs were in this show.
Yeah, Lita.
Lita and Leah.
And Penelope.
And Penelope, that's right. And then this is a walkthrough of it. It's a little shaky cam, a bit Blair Witch Project, but we should be able to stomach it for it's about 2 minutes. So we should add something rolling that just kept it steady, but I think this is like from a phone, probably,
Oh, well, who's to say what it would have been like to go back to the cosmic dark ages? Maybe it was shaky.
Yeah, well, it's true.
A little bit explosive, so.
So the really cool thing about this was, once you were inside, walking around inside it, you'd look back this way, and it was just amazing what would happen with the different elements. And so we were quite surprised when we actually installed it for the first time in a big space and lit properly and all that. Because we were working in a fairly dark, cramped space, and this thing's really inviting, and the whole idea of eons of time like that can be a little intimidating. So we wanted to, this thing was sort of funky, handmade, earnest, inviting. You know? It wasn't meant to be intimidating or like this is the universe.
Yeah.
It's more like we didn't want to scare the children. So it really is, when you walk through it, it's really appealing, and there's a buoyancy to it. It's just nice.
No, I agree. I mean, I think there's something about taking, again, something as immense as the cosmos and bringing it into some form of human scale, some comprehensible scale, and these like impossible tasks of representing them.
Right.
They're, whether they succeed or fail, and I feel like this definitely succeeded. They're still fascinating. It's still this human attempt to try to bring it back to us and to try to access it in some way that's human.
Mm-hmm. Mm-hmm. Exactly. There we are with the Australian Kelpie dogs. So that was a blast. We had a great time installing it. So that was the second time we've installed it. And it's available for installation if anybody wants to do it. So all my telescopes burned up in 2007. I had 5 telescopes, a 15-inch, the Observatory 10-inch, an array of other scopes, and lost the house, the studio, everything. And we had this property in Northern California, kind of 3 hours north of, 2.5 hours north of San Francisco. So we moved up there for a while, and I still wasn't reconnecting with astronomy. I mean, I'd go outside and look at the sky. It was pretty dark up there, but it wasn't until we got back to Southern California, because that's where I'm really based. We're both really based here, our careers. And we thought a good compromise was maybe Miners Oaks, Ojai area. And we our realtor, who is here, we found this great place, and it was a great deal, and boom, so we were there in 2009, and we moved down in 2010. And then I started accumulating hand-me-down telescopes, like a little 4-inch Maxitoff Cassegrain, and this 8-inch off Craigslist, this beautiful 8-inch reflector with a clock drive, which is, I prefer Newtonian reflectors like this because they give you real color rather than refracting telescopes which can distort color. And this one was a recent hand-me-down from the local bookstore. Hey, Russ, we got the scope we want to give you. So it's a little 4-inch thing, and it's just a blast to use, It's easy to use. And then Tony, up at the Lick Observatory, the archivist, had this in his garage, and he said, you know what, I never use it. Do you want it? I said, sure, because I made this thing 30 years ago. And so now I've got 4 scopes, and I'm a happy camper. It's like, this thing looks ugly, but produces beautiful images, like through the eyepiece. And from our front yard, you can see the Milky Way, and there's not many streetlights in Miners Oaks, and we want to keep it that way. And there's not too much light trespass from neighbors. People are pretty aware, when you walk down the street, you take a flashlight. So it's reasonably dark. Anyway, so I think that's it. Then I have a show. I have a show opening in LA on Sunday, actually, at Shoshana Wayne's temporary space on Jefferson, and have some of this. This is my studio work I've been doing, aside from the installations and residencies and all that. A lot of exoplanet things going on here.
Yeah, these works are kind of a nice, I think, as you said, accumulation of a lot of different things for you. A lot of, some of your more sort of detailed drawings figure into some of them, some of the text.
Right. Yeah.
But using that bioresin, was it through that look back time that you started experimenting with bioresin?
No, actually I've been using it before that. But it's just become the medium I use in terms of painting. Because I see these as paintings. They're collages. There's a lot of drawing in them, but they're also paintings because of the tint.
These also in part came about because of your shoulder injury, right?
Yeah.
From doing all of the globes.
From the globes, I did have horrible tendonitis, so I had to change my practice for a while. So I drew with sticks, dipped in ink, and the earlier examples were more like oil derrick type architectural shapes. Now it's gone pretty spacey. But, so this is called Epic Moon, and there's some lunar crater observations that I've done, and there's some cities, nocturnal cities, and then this list of people that have mapped the moon since Galileo. Cassini, some names you'd recognize, Cassini, all the way up to Gerard Kuiper, the Kuiper Belt. And the Lunar and Planetary Laboratory at University of Arizona was founded by him. So people like that, and some amateurs, a lot of amateurs actually, earlier in the 18th, 19th century, were doing the selenographers. They were the people mapping the moon. So that's the content in that one. And then this one's darkness at perihelion. So that's when an object is close to the sun orbiting. And this is sort of a wacky thing. It's got factories. There's a bit of the Anthropocene, what we're doing to our own planet injected into these, but also this sort of idea of, man, we're discovering all these other worlds. Maybe we should treat our world better because we're not like that Nobel Prize winner that just won the Nobel Prize for exoplanets said, we'll never get to another planet in another star system. The closest one is 4.2 light years, something like that, Proxima Centauri. And with our current technology, it would take 80,000 years to get there. So it ain't going to happen anytime soon. And we should take care of this beautiful world we have. That's what he was saying, basically.
Right.
So there's a bit of that sort of embedded in this. And that's actually from a salad thing from Vaughn's, like arugula or whatever.
Yeah, I was going to
came
ask
in
if there's
that.
recycled elements or,
Yeah, so there's a bit of plastic thrown in there for good measure. So basically they're collages, but they're on panels and on paper, and they're really stuck down. So I consider them paintings now, which is a change, and that's where it is. Kind of a gloomy title, but some of them are uplifting. Yeah. So
yeah, thank you. So if we have time for a few questions, we'll just open it up to anybody that has any questions about his work or astronomy, because he knows a lot more than I do.
So Russell, this idea of time, these things that you are drawing happen millions and millions of years.
yeah, well, like that star cluster in the show, the one up there, the globular, is 130,000 light years away.
It's an
So
interesting concept.
yeah, so it's the light's that old when you're looking at it. And there's galaxies I've looked at that are 50 million light years away, and it's a little creepy sometimes, especially if you're observing alone. It can be creepy. And they have weird shapes sometimes, spiral shapes and edge-on shapes with these bulges, the galactic bulge. Actually, we have our galaxies like that too. It has a large bulge in the middle, and that's where those globulars sort of are in the halo around that. So yeah, it all comes into play. And astronomers, professional like Tony, was telling me that he's really interested in this idea of, people think these discoveries just happen all the time, but actually astronomers work year in and year out and do data reduction and multiple observations, and then something will happen, like if you're lucky. You know what I mean? It's sort of like, maybe you'll get a MacArthur, but you know what I mean? It's like they can spend their whole life doing this research and nothing will break through. Or something will break through, or other people will get involved, and actually they're much more, the scientists work together. They share their research. Unlike artists who are like, no, it's one thing.
I was curious about the blue blob galaxy. So you said that was before reionization. So
No, it was during reionization.
can those actually be observed, or those?
Yes, they are observed, but they're like pixelated, and they're very. They do. I saw Garth, that astronomer, was showing me images and pixelated images of these biomorphic blue things. Like, yeah. And there's they're finding them farther back, and like when that Webb telescope goes up, the space telescope, the James Webb telescope, we're gonna see way back farther than that.
Things be seen before reionization?
During the cosmic dark ages, it was dark. Yeah. It was like everything was kind of dark.
Yes.
I was wondering if you were influenced by Chinese art.
No, to put it bluntly. I think it's beautiful, There was a show here a few years back of the poet that lived on a little
The
mountain
Artful
top.
Recluse?
Yeah, the art of that was mind-blowing. But no, it didn't. I didn't try to interpret that in any way for my own work. But it was inspiring, nevertheless.
You listen to Telestar in the studio?
No.
I get that vibe from your work.
I used to listen to on the radio.
Yeah.
I'm showing you how old I am. When I was at the Observatory in the Santa Monica Mountains, that one, I'd listen to Art Bell, late at night. And they'd be talking about Area 51 and and it would creep me out sometimes. And that Whitley Strieber guy, that supposedly was abducted. So you're listening to this stuff. And oddly enough, I've never seen a UFO. I've spent a lot of time under the night sky. I've never seen anything weird aside from stuff we put up there. just satellites going through the field of view while you're looking at the moon, for instance, looking at a crater, and all of a sudden something just goes like that. But there's lots of stuff up there. Yes?
The scale of this is so completely unimaginable. And it's possible to have a reaction of vertigo or even terror at the immensity. I kind of wonder how you, or even just see it as wonder. I just kind of wonder how you handle that.
I've been criticized for saying this, but I find it I find it comforting because I feel like I'm connecting with it, like the beauty of it, and some of the science behind it, but primarily the beauty. I mean, there's star clusters that I look at and I gasp. Still, like I've looked at them 100 times or 1,000 times, some of them, but.
But I think that's a really important function of your art.
Right. Yeah, I think so. And I have friends that don't understand it, I have a New York photographer, very close friend of mine, just says, how can you deal with that? Doesn't that drive you crazy? I mean, it's like, it makes me paranoid, it's like, no, it's actually, it's sort of like somebody that skin dives or, whatever. You get close to nature somehow in your own way. Yes.
I'm curious how the frame of the telescope, the aperture, affects your composition at all, especially if that in more of the globes.
Well, no, I mean, the aperture is about what you can see. I mean, the bigger the telescope, the more you're going to see. And so, the drawing of the star cloud in the show up there with the dark spots, that was through a large telescope, at a dark site. So,
It has effect on some of your art in that you drew into circles.
Yeah.
Right. Oh, well, no, yeah. I mean, yeah, looking through the field of view thing, yeah. I mean, yeah, formatting, yeah. That's why I was drawing circular, and then that translated into globes later. Like I thought, okay, this could work on a sphere, quite nicely. So
You have some drawings too. I think I saw in your studio, right, where the matting was very thick and you kind of cut into it a little bit so that it feels slightly more.
For these double and quadruple stars drawings that were actually colored in and inked in, and then I had them cut museum board at an angle, so it's like you're looking through an eyepiece, kind of. And then I'd write what it was, like in this cornball, 6-inch Newtonian at 176 power, blah, 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 beta something, whatever star it was. And those were sort of like hearkening back to the more classical things, in a way.
Question about your globes. First of all, a lot of questions about your globes. Are you still making them? How many have you made? And the one that hangs in our gallery all alone has such presence, and yet the beautiful shots when you see them in mass are kind of different.
Yeah.
They dictate the gallery as opposed to.
Yeah. Well, they emphasize the architecture in a funny way, because.
Do you need them to be in mass singularly? Do you keep a group together like a star cluster, or do you sell them off individually?
No, they're sold individually, but they do function well in like the architecture, it's because they're floating. So you really do notice the architecture as well of the space they're in, because there's nothing else. There's nothing on the walls usually. But they're done individually, and then they just sort of hang together. But I try to keep them perceived as drawings by hanging them at that level. Yeah, yeah. Unless it's like the embassy in Beijing, where you have a whole atrium that they want to fill, or something like that. But
And is it ongoing? You're still making these books?
I make them under commission only. because they're rather expensive to fabricate, and they take quite a while to make. So, yeah, I mean, but I'd be happy to do a commission. You know, who wouldn't, right?
You're looking at me.
Well, are you raising your hand?
I am. So am I right in understanding that you did all the writing on the globe
Hmm?
as it was in the globe shape?
Yes, they're all drawn in the round.
How in the world did you stabilize your hand and the globe in the course of doing that? Because it is so.
You find
The letters are
You-
generally the same size throughout.
right. You find a position that works where you're stable. You know, on the big ones, I had to roll it. You know, I had to roll them around. So I put glassine over packing blankets, and then I'd roll them around and work on them that way. Sometimes getting on a ladder.
Your arm during that.
Yeah, well, that's why I got tendonitis. 'Cause you know, drawing in the rounds is difficult. Yeah.
And you did a commission with the globes up in a winery, up in the wine country?
Yes,
Where is
for
that?
Hall Wines in St. Helena. Yeah,
And how many globes did you do?
6. Yeah, yeah. They have.
Those were not astronomical globes, so we didn't include.
Yeah, those were actually terrestrial globes. Some with text, some without. Of parts of California, actually.
But you did 2 specific to that, and the other 4 were existing globes that we showed them.
It's like Cape Mendocino, the Eastern Sierra, their vineyards, Napa Valley at night.
There's one astronomical.
Right, Napa Valley at night, and then Cape Mendocino. What was the other one? I can't remember. But so those were more terrestrial things.
Installation.
Yeah, it's in an old building where they used to squish the grapes, and there's this runner, this metal gutter going down the middle of these big wooden plank floors, where they'd squish the stuff and it would drip out into these big barrels. It's pretty great. It's a stone building, so that was cool. Yeah,
It's specifically where?
St. Helena. Yeah,
Oh, in St. Helena.
Yeah.
All
Any
right.
other questions?
I think that's it. All right. Thank you so much.
Sure. Thank you. Thanks.